Hello, children. It's Mr. Wicklehouse. And today we are doing the law of sines. How great! Woo! So, the law of sines. This is something that we can use for triangles that are not triangles. So what if the triangle that we're working with is not a right triangle? Well, we can use the law of sines to find the sides or the angles or whatever we want, and all it really is a set of ratios that are set equal to each other, so it's a proportion. So the law of sines tells us that the sine of angle A divided by the side A is equal to the sine of angle B divided by the side of B, and the sine of angle C over the side C here. They're all equal to one another. So this is a way for us to be able to find pieces of triangles that are not right triangles. So let's look at some super duper great examples. Here we go. So find side YZ if angle X equals 33 degrees, angle Z equals 42 degrees, and XY equals 27. So I always recommend this for problems anyway. You should always draw a picture if you can. So let's draw a picture of the triangle. Here's our pretty triangle. Look at this thing. Man, what a lovely triangle. And this will be X, Y, and Z. Wow, amazing. So let's label the parts that we know. XY, that's 27. You might say that that 27 is also side Z since it's across from the Z here. X is 33. That's this angle here. It's 33. Z is 42. Now we're looking for YZ. Well, we can use the ratio of sine Z over side Z, and that's going to be equal to the sine of X over side X, and here's side X, which is also XY. Nope, sorry, it's also YZ. YZ is side X. So let's plug some stuff in. Sine of 42 over 27 equals the sine of 33 over X, since that's what I'm looking for. Okay. I'm going to multiply both sides by X. Multiply both sides by 27, and we end up with X sine of 42 is equal to 27 sine of 33. Well, since this is X times the sine of 42, then I can divide both sides by sine 42 sine 42. And since that's the case, then I end up with X being approximately 21.98. Bam. All done. How easy was that? It's just a proportion. Plug in your numbers that you know and solve the proportion. It doesn't get much easier than that. But in case we're still confused, let's do another super duper great example. Okay, this one we want to find angle B if angle C is 65, B is 13, C is 29. So again, let's draw a pretty picture of a triangle. Here's our pretty triangle. That one's a little bit better than the last one. We'll say A, B, C. So that means this is side C, this is side A, this is side B. Well, we're looking for angle B this time, so we're looking for this guy. What is that guy? Well, I know that C is 65. I know that side C is 29. I know that side B is 13. So, let's set up our proportion. And we'll use that the sine of B over side B is equal to the sine of C over C. Plug in what we know. Sine B I don't know because that's what I'm looking for. But I know side B is 13. I know that C, angle C, is 65. So the sine of 65. And I'm dividing that by 29. Do some multiplication here. Multiply both sides by 13. I'm not going to bother multiplying by 29 because then I just have to divide by it anyway. So now I've got sine B equals 13 times the sine of 65 over 29. Man, how great is that? Now, since we're looking for an angle, I am going to use the inverse sine function because this is just a number and the inverse sine function is going to allow us to go back to an angle. Okay, so now I can say that B, angle B equals the inverse sine function times 13 sine of 65 over 29. Okay. And when I plug that into my handy dandy calculator, I get that B is approximately 23.97 degrees. Cool, huh? Alright, we'll do one more example. If we could keep this thing in focus, and it's not going to. So hold on, let me get it in focus again. There we go. Alright. So this says solve the triangle. So we want to solve the triangle. What does it mean when it says solve the triangle? It essentially means that we need to find all of the angles and all of the sides of the triangle. Okay. Well, in triangle QRP, the measure of angle Q is 36, the measure of angle R is 86.4, and the side P equals 22. Alright, so again, let's draw a picture of our triangle. Here's our triangle this time. Oh my, that third side got a little wonky on me. Let's see, Q, R, P. I know that angle Q is 36. I know that angle R is 86.4. And I don't know what angle P is, but I do know that side P is equal to 22. I don't know what side Q is, and I don't know what side R is. So what do we have to find here? We have to find angle P, we have to find side R, and we have to find side Q. Okay? Well, to find this angle, we're not going to use the law of cosines at all, because we don't need to. Or, sorry, law of sines at all. We don't need to. Because we already know two angles, and we know that the three angles of the triangle add up to be 180. So, angle P is equal to 180 minus 36 minus 86.4, which in turn is equal to 57.6 degrees. So P is 57.6. Okay. Now that we know that, I could start using my law of sines because I have the angle and the opposite side. So I'm going to do sine of P over P is equal to, which one do we want to do? Let's do Q. Sine of Q over Q. So sine of P, sine of 57.6 over 22 is equal to the sine of 36 over Q, because I don't know what Q is. Well, multiply both sides by the denominators, then divide by the sine of 57.6, so then I get that Q equals 22 sine 36 over the sine of 57.6, which then is equal to 15.3. So I know that side Q is 15.3. Okay? Now, I can do whatever one I want. I can do P again, or I can use Q. Let's just do P again because that's just going to be easier. I'm going to do the sine of P, which is 57.6, divided by 22, which is the side, and that's equal to the sine of R, which is 86.4 over R. Again, I'm multiplying both sides and dividing, so I get R is equal to 22 times the sine of 86.4 divided by the sine of 57.6. And that is going to be equal to R, which is 26. That's it. Pretty easy, huh? Set up the proportions and solve them. Now you know how to use the law of sines. See you later.